Today we are going to be talking about discounting. Okay, so we're going to talk about interest and how money that you might have invested would grow over time. And then we're going to look at the present discounted value of future payments that you might receive. So we're going to look at the present discounted value of one payment you might receive 2 years in the future. And then we're going to talk about the present discounted value of a stream of payments, which I'll show you has a number of uses in a variety of contexts. So there are three terms that we're going to be needing for this lecture. The first is principal. That's the amount of the assets that you have in your investment. So for example, if you have a bank account and you have $200 in savings in that account, then the principal would be $200. And next, we're going to talk about the interest rate. The interest rate is the percent that you get as a return on your investment, on your principal. It's either expressed as a percent or as the fractional equivalent. It's like 1% in fractional terms would be 0.01. And lastly, the interest is the dollar amount of your return. So for example, if your principal is $200 and the interest rate is 1%, or expressed in fractional terms, 0.01, then the interest that you would earn is a $200 of principal multiplied by the interest rate in fractional terms, 0.01, or $2. So the interest would be $2. And at the end of the period, when the interest accrues, the amount in your account would be the original principal amount of $200 plus the interest that was earned, $2. So in total, it would be $202. Okay, so let's look at how money grows over time. I'm going to start by defining A, with a T subscript, as the amount that you have in your bank account in period T. We're going to say that right now is period 0. So the amount that you have in your bank account right now is going to be A with a 0 subscript. Okay. Next period, the amount that you're going to have is going to be equal to the amount that you started out with plus the interest that was earned. Okay, so plus the amount you started out with times the interest rate, noted by R. Now, if you look here into this formula, into the highlighted part, that is equal to the interest. So we have the initial amount, A0, plus the interest earned, where the interest earned is equal to the beginning amount times the interest rate. Now, you might be able to see that this simplifies to the amount you started out with, A0, times 1 plus the interest rate, R. Okay. Now let's look at what happens 2 periods from now. The amount that you're going to have 2 periods from now is going to be equal to the amount that you had 1 period from now times 1 plus the interest rate R. Okay, now the first thing I want to do is actually rewrite this expression. Okay, so we can plug in for A1. It's equal to A0 times 1 plus the interest rate R. Okay, so this highlighted part here is simply equal to A1. That's what we plugged in. Now, if you look back a little bit further to the left, you see that A1 was multiplied by 1 plus R. So we still need to multiply this highlighted part times 1 plus R. And you may see that this can be simplified to the amount you started out with times 1 plus the interest rate squared, raised to the power of 2. It's raised to the power of how many periods from now we're looking at. And so you might guess any arbitrary period T from now, if you keep on reinvesting the interest at the same interest rate R, the amount you're going to have in period T in your bank account is going to be the amount that you started out with times 1 plus the interest rate raised to the power of, not 2, of T. So, one other quick note before we move on to the next topic. I wanted to talk about the rule of 72. It comes pretty close to telling you how much, if you invest something today at sort of a constant interest rate, how long it will take for that amount to double in value. the way you actually use this rule, you take 72 and you divide that by the interest rate. And that gives the number of periods or years before the investment will double. Okay, so for example, if the interest rate is 4%, divide 72 by 4, it is equal to 18. It says that it's approximately true that whatever you invest today at that 4% interest rate will double in 18 years. Okay, so next we're going to look at the present discounted value. So previously we were looking at some amount invested today. How much is that worth as some number of periods in the future? Or if you invest, each period, how much that's worth at the end. What we're going to do next is we're going to look at the sort of the opposite of that. We're going to look at the present discounted value, which is going to tell you how much a certain amount received in a later period is worth today. So suppose that someone has promised to give you $100 a year from now. How much should that be worth to you today? Now we know that it should be worth less to you today because if you had $100 today, you could invest it in something and it would grow to more than $100. Right? It might be something like if you had $96 today and you invested in something, a year from now it might be $100. Okay, so that's a basic idea. So we're going to reverse the calculations that we did earlier. Okay, so let's look at how we calculate the present discounted value. Now, I want you to remember that we had derived this formula when we were looking at investment growth. We were saying if you start out with some amount A0 in period 0, and it grows for T periods, the amount you'll have in this investment in period T is equal to A0 times 1 plus the interest rate R raised to the power of T, where T is the number of periods it could grow for. Okay? Now, what we're going to do now is we're going to calculate the present discounted value. We want to start with some amount T periods from now, and we want to know how much that's going to be worth today. So let me write to sort of change notation to make clear that we're doing something a little different. Let me write that the amount that we're getting T periods from now is VT. So like this is the promise that you'll be given $100 some number of periods from now. And we want to know what that should be worth for you today, given that there's sort of an opportunity cost of getting money later. So what do we want to do? We want to solve for the amount that it's worth today. We have to solve for A with a 0 substitute. So if we were to divide both sides by 1 plus R raised to the power of T, we would get that the amount that you get T periods from now divided by 1 plus R raised to the T. Right, so you're going to get some amount VT, T years in the future. How much is that worth to you today? Well, it should be equal to that amount divided by 1 plus the interest rate raised to the power of T. We call the amount that this promise of receiving some money in the future, we call this value today as the present discounted value of that future payment, which we might abbreviate as PDV, present discounted value.